Great. Okay, we can get started. Thank you everyone for coming. It's always a pleasure to welcome our guests from Cadence, and great to introduce Doug, our speaker, which is really like a mentor type of session today. Doug is sales rep and director of sales for Cadence for not just UCLA, but the whole Southwest US, Australia, and New Zealand. He's been in EDA industry for more than 3 decades, and he's experienced the whole chain of technology, from being an engineer to be a CAD manager to be a sales director. And as you know, technology is worthless if you can't sell it, right? So it's very important, I think, to understand the whole interplay of technology. How do you take your technology, your ideas out in the real world? What it takes to do, and especially these days, I think it's a really great time to discuss these topics. How do you position yourself for success in a career in the face of current job market? So that would be kind of really a discussion for today. Feel free to interject with any questions. This is meant to be interactive and informative, and it's great to be able to leverage the knowledge and vast experience that Doug brings us. So without further ado, Doug, it's all yours. Thank you so much.
Thank you, Professor Dion. I appreciate it. Greetings, everybody. Okay, so we do want to make this interactive, so I will ask you questions. All right, I'll point at people and actually ask questions. So don't feel that you can't answer. Please just feel free and be comfortable. As Dion said, my name is Douglas Willmore. I am the Director of Sales for Cadence Design Systems. And you might all know who Cadence Design Systems is. We sell design IP, software tools for design and analysis of electronic systems, not only semiconductors, but entire systems. We're investing heavily in branching out of the chip world and out into the system world. Because what we found is most of our customers are actually, the growing customers, I should say, are systems companies, not the old fabless semiconductor companies. So those are the growing customers. So when I say sales in this realm are really interesting. I have an engineering degree. I don't remember how to do any of that stuff. But I do a lot of reading on technology, and I try to keep up on the high level on what's going on, right? So if you have any questions, just like I said, feel free to ask. So I'm just going to talk about kind of where I'm from. I'm from that little blue cross up there, a little town called Kalispell, Montana. I am the youngest of 7 siblings, and the youngest of 20 cousins, and I am the only one that went to college. So I drove to Texas. My plan was to go to the university down there. I ended up moving there. I had a couple of jobs while I was trying to get into college. One of them was selling encyclopedias door to door. That introduced me to sales. You knock on a door, the door opens, you introduce yourself, and you introduce your product, which is a set of books. You know what encyclopedias are? Okay. So a set of books that stretches, kind of the length of that screen, and it's $1,500. And then the door slams in your face. And then you move down to the next door and knock. And there was a gentleman who was my sales manager, and he would drop me in the poorest neighborhoods of any place he was driving, right? The only set of encyclopedias I ever sold working for that man was right in his apartment complex, because I drove down, spent a lot of money on gas, and he and a couple other guys were like, well, we're not going to sell today. We're just going to play Dungeons and Dragons. And I'm like, no, I need to make some money. So I went out, a couple of apartments past his, and sold one set of, and my only set of encyclopedias in the entire 6 months that I did that. I learned a lot about sales. I learned a lot about rejection. So, and what I learned was, don't take it personal. You're going to fail. You're going to fail. I'm a big failure. I'm a huge failure. I fail all the time. But unless you're trying new stuff, you're not going to fail. And unless you're trying new stuff, you're not learning, and you probably won't succeed either. So from the Texas encyclopedia sales, I tried another door-to-door thing while I was in college, which was selling insurance door-to-door. That one was a little bit better. Made a little bit of money for college, but then I decided I should just focus on jobs around college. So that's what I did. I was a lab assistant. I was the activity director at the school for a while. And then I also was a bellman. I carried bags for people at the Sheraton Grand Hotel out by DFW Airport. So that was Texas. And all this time I was interested in aerospace because when I was in Montana, I learned how to fly. I had the good fortune to go to a high school that was fairly innovative. And the math teacher also taught a science class that was ground school for private pilot license. So I got my ground school for private pilot's license in high school for free. And then I changed irrigation pipe for 3 years in a row, which that job doesn't exist anymore because irrigation is automated now as well. But I changed irrigation pipe for 3 years in a row and made enough money to start flying and got my private pilot's license actually just out of high school. I was 17 years old. Why they let a 17-year-old fly an airplane by himself, I don't know, but it was a lot of fun. So from there I went to Texas. Then I basically subscribed to a lot of magazines that talked about the aircraft industry, aerospace, and everything I read, every article I read said that Los Angeles was the place to be for aerospace. So I moved to Los Angeles. I sold everything I had in Texas. I bought a motorcycle. I rode with some friends I befriended at school. We rode motorcycles from Dallas, Texas to Wisconsin where they lived, across the northern states, and then down to Los Angeles. And dropped us out in Orange County, which was, I don't know if you've ever been to Beach Boulevard in Orange County. It's a very long street. And we would ride up and down and try to figure out where we were, right? So that's where I started. We started my last year of school here, and got into an aerospace company a little aerospace company called Learstronics that did flight control computers for nearly every military aircraft that was built at the time. And flight control computers, the first aircraft that those went in was the F-16. And it was an analog flight control computer. There was no digital in that system. It was very interesting. Subsequently, there's a lot of digital in flight control computers these days. So that's my beginning. And from there, as an engineer, I worked on CAD tools. I worked on one of the old CAD computer-aided design tools and software. They sold both, back in that day, they sold both hardware and software. And that was called Daisy. And it was an Israeli company. They merged with a company called Cadence and became Daisix. And that company started in 1981 and went bankrupt in 1990. And at that time, Cadence Design Systems was coming up, Synopsys was coming up. So that the EDA industry goes back to really the late 70s, early 80s. That's when, purpose-driven corporations were founded just to support the kind of general electronic design automation industry. So I kind of based this discussion loosely around a book called Crossing the Chasm that was also written in the early 90s. I first wanted to kind of talk about overcoming challenges. We all have challenges that we have to overcome. One of the things that you have to work on basically is understanding that it's a mental block, some type of mental block, right? So I'll channel your mother and say, rest well, eat right, and exercise. That helps a lot, right? And then get out into nature. I think that a lot of folks now, we all live in cities and we suffer from nature's separation anxiety. That's a new term that I read in one of my recent readings. So it's really good to get out in nature. I try to get out at least 3 or 4 times a week, either to hike or or surf or swim or something. So you got to do that. And of course, all of you know that you have to break things down, take a step back if you're really fixated on something, and you know, consult a friend or a mentor, and you know, try not to fixate. Try not to fixate on the outcome, right? If you start doing that, you start projecting, and that really starts to lock up your brain, right? So, crossing the chasm, your journey into work life from academia. That's a difficult one. For me, I knew exactly what I wanted to do. I wanted to work in the aerospace industry. So I had an electronics engineering degree, did a lot of interviews, picked the aerospace company that I wanted to work at here in Southern California and started working. I had an opportunity to go to a company called Applied Materials up in San Jose at the time. Wonder what my career would have looked like had I taken that role. But I wanted to work on airplanes, so I stayed here in Southern California and worked on airplanes. I did that for about 8 years. But the only thing I struggled with actually in my school to work life was I had to rationalize going to work for a defense contractor. And that was kind of a difficult one for me. And what I find is there's a lot of students coming out of school that have that same rationalization. They can't come to grips with building defense equipment. That I will use the euphemism defense equipment, right? Because defense equipment can also be used for other reasons. So it's a tough rationalization. But I just love the aerospace industry, so that I made that rationalization, I made that jump. For some of you, there may be other issues that you're coming up against. You know, just what does your career look like? Where do you want to go? Do you want to go to a startup? Startups are great. There's some of the startup companies. I have other startup companies in Southern California, many of them actually, that come to Cadence because Cadence is the kind of the analog leader, and so most folks are actually doing some kind of analog design, albeit some of it's small. We have a lot of image sensor companies in Southern California. My hope is that you all would stay here in Southern California and live and work here. So back to what you're looking at, whether you're looking at a startup, a public company, or a private company, there's a notion of social businesses now, and of course nonprofits. Don't know very many nonprofit engineering companies. And I'm hoping maybe some students or someone in the future will start some social businesses based on engineering. But it's a hard thing moving from academia to work. There's some expectations that you have, what you're going to be working on, the challenges that you want to work on. I would say that some of what Michelle is doing is very challenging. Going to some of the older companies in Southern California would be challenging as well, although what I have found in my experience in talking to engineers, the larger the company that you go to work for, the narrower the focus of your job. If you want to expand the focus of your job and do a lot of different things, you're better off going to work for a smaller company because you will be asked to do a lot of different things and the challenge will be higher. The larger companies have a role for you and it's going to be fairly narrow. So that would be one of my recommendations. Okay? Now we can move on to the actual discussion topic, which is Crossing the Chasm. This is a book written 1991, revised a couple of times. Jeffrey Moore is a fantastic author, and he breaks down the marketing problem of bringing technology from what you see there on the left, which is the technology enthusiasts and the visionaries, into the mainstream market where you have pragmatists, conservatives, and skeptics. Now, we work with this on a daily basis because we have within each one of our customer bases, when we bring a new product out and say, hey, look at this is great, we have the enthusiast that picks it up immediately and starts designing with it and loves it and talks about it. But then you have this chasm. And this chasm is an interesting thing. It's a mental chasm right here. It's a personality chasm. Because the pragmatist looks at that and they really don't have very good expectations of grabbing the newest, latest technology and using it, because there's going to be a lot of work involved in that. There's going to be things that don't work properly. There's going to be things that don't work as advertised. There's going to be a lot of work that you will have to do around the product. In the software realm, it would be a lot of scripting, a lot of automation that you'll have to develop yourself to make the product work. And that's why pragmatists don't like to jump on this as soon as the technology enthusiast. The technology enthusiast will be willing to do all that work, that extra work it takes to actually make this thing happen. But if it's a whiz-bang new capability, they'll basically apply themselves and do that extra work. The visionary, he's just got great ideas on what that can do. And after the enthusiast within our customer base makes it all work, he'll start using it as well. But the pragmatist won't do it because they want a product that's ready to go. There's training for it. There's lots of documentation for it, and it's going to be, just ready to go out of the box. And oh, by the way, other pragmatists are using it, because he will not listen to anything the visionary or the enthusiast has to say. He wants to hear other pragmatists using it, which is why that chasm is there. Because if you have a product and you don't have a pragmatist who has used it and will tell other pragmatists that it works well, you won't sell to that pragmatist. And that's why we have this chasm. And this happens in technology all the time. How many of you own cars in here? An electric car or a internal combustion?
Just gas.
Okay. Okay. So for another issue with technology is expensive. New technology is expensive. I'm going to go to the next slide because I think it helps me kind of talk about this, because I have stories on this. When I first moved into sales, people had Palm Pilots. Remember the Palm Pilot? It was just a personal data assistant, they called it. It would hold your contacts, but it wasn't connected to the outside world. It wasn't a phone. The first phone that had a Palm Pilot built into it that I owned was this thing right here. You've probably never seen one like this. They still sell these. They're smaller, they look better. But this thing came out, and that was the cat's meow. It was a Palm Pilot and a phone all together. And so I had my contacts, I had my email, and I could send texts. It was phenomenal. And it changed everything I did. I worked for a startup company at the time. Just after I bought this, the VP of marketing bought it, the CEO bought one, the CFO bought one, and several of the other sales guys bought one. So those were the early adopters. Those were, the visionaries that said, this is a great tool for what I can do. But you don't hear about the Kyocera smartphone. That's not the phone that everybody uses in here. I would say we have a combination of probably 50% Apple, 50% Droid in here. Would I be right? Let's see the Apple phones. Apple phone hands. Okay. Droids? Oh, much fewer Droids. Wow. Okay. So this is what happens, right? Now, before we had the Kyocera smartphone, of course, the Newton came out, and this thing from HP came out. This thing from HP was great. Everybody, if you were a technology person, you loved that thing because it was a full-on computer, albeit the keyboard was kind of small, as you can see the pencil there. And the Newton was great too, but really the handwriting, the pen stuff didn't work as well as advertised. So both of those fell flat. And that was one of Jobs' failures, but he kept working, right? Another failure of Steve Jobs was Next Computer. Anybody heard of Next? Yeah, Next Computer, awesome. Way ahead of its time. Too far ahead of its time, it failed. So technology is kind of interesting. this notion of coming out with a great technology, you have to come out with a technology when the market is ready for it. If you come out too soon and you try to push it into a market that's not ready to accept it, you will burn a lot of capital. I mean, hundreds of millions of dollars, and you won't make it. And then the guy that comes in 2 years after you, he will spend a lot less money and he'll make it because now the market's ready. So you kind of don't want to be a market maker. You kind of want to be in a position where the market's already made and it's ready to go. So I'll talk a little bit about the other phones here because maybe you've seen these. There's a handspring, that was also a palm with a phone built around it. Of course, BlackBerry, that was research in motion. They owned the market for several years. And when the iPhone came out, they weren't worried and they didn't innovate until it was too late. And the Apple phone and the Galaxy phones just took them out. They're still around, research in motion. They sell software for enterprises, but they don't sell very many devices. So it gets back to technology. The market for technology, especially if you're talking business to business, like the kind of technology that we at Cadence sell and our competitors, we have a very small industry. The EDA industry is probably, I would say EDA now would be, with IP sales, about $10 billion a year. And we support a multi-trillion-dollar a year semiconductor business. And for some strange reason, the electronic design automation business can't grow very fast, although we support it. I think if you looked at electronic design automation in the past, I'll go to the next slide. These are the general kind of purpose EDA companies that are around or have been around. Daisy, of course, I told that story. That's no longer around. Magma Design Automation is no longer around. Vericity was acquired by Cadence. Mentor Graphics was acquired by Siemens. Now it's called Siemens EDA. These two in the corner, these are actually companies, little startup companies that I worked for. They did not make it across the chasm. They had a great technology. We would go into companies and some enthusiast, technology enthusiasts would grab it and go, this is great, but we never could make it into where the pragmatists live. And these two were actually hardware emulation companies. And now Cadence we have an emulator, and it was the one that I used to chase around when I worked for these small companies, because it's the one that still exists, and it's probably has 65 to 75% of the market for emulation, big digital ASIC emulation. The ability to put an NVIDIA chip and emulate it all at once while you're running software on it it's invaluable to NVIDIA. There was a 2008 article in Forbes magazine with a picture of these hardware boxes that Cadence sells, and the CEO of NVIDIA said, wouldn't have a company without this, because it's a qualitative kind of simulation. It's pixels. It's the video that you see, and you have to be able to run the software on the hardware to make sure that works. So this whole thing about hardware, software integration, what Dion talked about, which is reconfigurable, hardware reconfigurable, runtime reconfigurable hardware, that is going to be the next big thing in electronics, I believe, as well. I have a lot of experience in that respect, right? Because I work for a company that acquires a lot of companies, and I've seen a lot of acquisitions happen. So Vericity, now that was an interesting one. That was acquired by Cadence. Now, Vericity had absolutely the best verification capability on the planet. For 10 years, they had started to develop the constrained random testing capability for digital designs. And constrained random and coverage driven was what they did. And they had their own language. It was called E. Have you ever heard of E? Anybody ever heard of E? Yeah. It was phenomenal. Cadence acquired this company. This company had pretty good market share. Intel, TI, some of the big ones were using them. Cadence acquires this, and the thing that happened immediately was that our competitors, Mentor Graphics at the time and Synopsys, did a marketing thing, a marketing plan. Together, they went to the industry and said, it was genius. It was escape E, right? In other words, get off E because Cadence is gonna proprietarize it. Is that a word, proprietarize it? Anyway, make it a proprietary language, and then you're stuck, right? Cadence didn't do that. We put it out in the IEEE. We made it, but the sales and marketing people within Cadence did not do a good job of taking what Vericity had created and deploying it out to the sales team. And the sales team, all they asked for was, give me a system Verilog story that Synopsys and Mentor have, right? So now you have two big competitors against Cadence pitching System Verilog. And System Verilog, that's genius marketing. System Verilog. You think it's great, right? I know Verilog. You guys probably all have written Verilog, right? So that's genius marketing. And then you have this other thing called E. Well, I don't know what E is. I don't know what that is. That's kind of, it's I'm a little afraid to do that, right? That's the crossing the chasm thing. The pragmatists all know what Verilog is. That was the most genius thing that Synopsys did by calling this language, which is really a little bit of Superlog, a little bit of VHDL, and then the original Verilog language all munged together into an object-oriented verification language. It was still a terrible language, actually. It was not purpose-built. It was kludged together. But you know what? Just like Betamax versus VHS. The technology that is not as good wins because the marketing was better. So to get back to your question about purchasing companies and then integrating them, a very difficult thing. Shruba and I were just talking about one of the recent purchases that Cadence has made. And we think it could be done a little more smoothly. So what happens is you have the engineering guys in the company that's being acquired. And they think, well, since you acquired us, we must be the best and the greatest. So of course you would want to use our technology. And then the acquiring company, maybe that's not why they acquired them, right? But it doesn't matter because psychologically the company being acquired thinks that that's why they're acquired. Why not? We got the best stuff, right? Well, the acquiring company might be just taking it just to get the market share. We're just going to get this, and we're going to kill the tools, and then we're going to sell our tools to all your customers. That happened between this company and a company called Magma Design Automation, right? That company acquired Magma, and they got all the engineers in the room, and they said, your tools are really bad. You're going to start working on them, and you're going to work on our tools, and then we're going to take it to market. What happened there was good for Cadence because a lot of the engineers were a little disgruntled by that, and they came to Cadence. And that's what started the Cadence digital tools to become better and better and better because those Magma guys were very smart. They were very sharp, and they did build great tools. Their problem was they were the fourth company in a very crowded space. And their market share, although it was stable, the revenue for that stable market share kept going down year after year because they have to keep discounting their software because the other companies kept discounting their software. So it was a race to the bottom. And that's what happens a lot of times in markets. It has nothing to do with technology. You can have the best technology in the world, but if you have competitors with also ran technology or maybe not as good and they're driving the price down, you can't make it. It'll be very difficult to thrive. That's why you have so many companies that get acquired or go out of business completely. I mean, the interesting thing about semiconductors are the fabs. I mean, we have one place in the world really that does 90% of the complex chips, and that is Taiwan Semiconductor Manufacturing. It's amazing what those people were able to do. because that is a very low margin business. It's very difficult to make money at that business. And every IDM, Texas Instruments, everybody, AMD, everybody that had their own fab, they're like, we don't want to expend this money to have a fab. And Taiwan Semiconductor Manufacturing said, come on over here, we'll do that for you, right? And they've built a phenomenal business. There's 24 fabs in Taiwan, everything from 180 nanometer down to 5 nanometer in production. They're looking at 3 nanometer very soon in production. So, and now I understand we're going to build one, they're going to build one in Chandler, Arizona, and they've just increased the size that fab will be. And then we've got Global Foundries. Smallest technology node they're going to use is 12. They dropped their 7 nanometer line. It's too expensive. It cost TSMC, when they did their 7 nanometer line, I believe it cost a little over $10 billion just to set that line up and get it going. So the 3 nanometer, I'm sure, is going to be $12, $15 billion to get it set up. That's a huge sink of assets to get to the next level. And I think, the gentleman that we met that was doing quantum in the break room, he's not here, but maybe some of you guys are looking at quantum or quantum computing, which that really goes over my head. But I know that there's some kind of semiconductor content in quantum computing as well. But yeah, the next big thing I think that just is Dion's completely correct, and you heard Michelle talk about it, is the runtime reconfigurable capability. FPGAs are very popular. Most FPGAs are actually manufactured at TSMC, the popular ones. Those FPGAs are actually complex, heterogeneous packages of analog and RF sections on an interposer with a very large, highly integrated digital section. TSMC is the one that does those things, and they're quite phenomenal. Intel's getting into it. They're a little bit behind, but they're pushing that envelope as well. So more than more is what we call it, heterogeneous packaging, where we have chiplets on interposer, so you can have different technologies in the same package is another thing that's fast becoming the next big thing, because we have to do it. There's an academic network that we have. We support a lot of universities, and we have several different ways to support them. One of the things I want to draw your attention to is this online training. So the digital badge, that's kind of interesting. So our customers actually look at that. If you have gone through this training, you have digital badges on your resume, that's actually, people are starting to recognize that as a valuable thing to have. So a few things about the tools. So you ask, how are we doing on automating the tool set? So we are starting to build machine learning into a lot of the different tools. Digital place and route was one of the first one. That's pretty low-hanging fruit for machine learning, because there's so many different iterations that you go through to try to get timing to close. You have clock tree synthesis issues, you have clock tree balancing, you have all kinds of issues that you just try different things constantly, and the digital engineer who understands layout, he knows how to tweak these parameters, and he'll do runs and runs and runs, but some of these runs will take 3 days. So you want to be able to make sure that you're changing the parameters properly. You don't want to just waste a 3-day run. So one of the things we're doing is building ML into our digital place and route. I don't know that it's here. Cerebrus, that's the first one on the IC Digital. So it's a AI layer above the other digital tools that you see there, and it runs all kinds of different iterations, and it's had very good results. So we're moving this ML capability into a lot of our different tools. So that's one thing we're doing to try to augment the efficiency for all you guys when you get out. So let's go to I'm just going to go straight to the digital badging I talked about a little bit. That's a good thing. I'm going to go right here. So I think we have, what, 40 internships right now? And we are hiring. I don't know how many recs we have, but we are hiring. We have a lot of recs in all shapes and forms. So all the way from, R&D, which they're software developers, to application engineers who really need to be analog and RF and digital design engineers that understand what the customer is going through. So we're hiring a lot. So if you look at this and take a shot of that QR code, those are the internships that we've got open right now. I think we got, 40, 45, something like that. We want to try to close those out before the end of the year, I believe. So. All right, any questions? What I mean is both of those when I say RF, because it's okay if it's CMOS RF, and mimic designs are important as well.
Yeah.
Let's separate those. Okay. So emulation I consider as EDA. I'm steeped in the hardware background. Okay. So I've worked on emulators as well as prototyping, as well as simulation accelerators. So in a perfect world, that would all be one system, but it's not that way. Cadence's emulator is actually very different than anyone else's emulator, and there's only two other ones really. Cadence's is a massively parallel Boolean processor. It's actually a technology that IBM created years and years ago. And then we adopted that technology. We build the chip ourselves. It has a massive amount of RAM around it. And basically right now we have 4 billion gates in one system. So we can do a very large ASIC. And it runs fairly fast. We also have an FPGA-based prototyping system that we sell, but the front-end compile for both of those is the same, whether you're going to our Palladium emulator or whether you're going to the Protium FPGA. And the FPGA prototyping tool has no visibility. So you can't really debug using that thing. You have to pop it back into the Palladium emulator, and then you have a full simulation style visibility. Okay, so that's the hardware part of what Cadence sells. Cadence sells IP. We don't sell very much. There's other big IP vendors. One of the best pieces of IP we sell is a little DSP processor core. It's not really a solid core. What it is a algorithmic exploration tool. And you can customize it in any way you want. And then when you push the production button, out pops the assembler, the linker, the debugger, a system C model, the ISS, the RTL scripts for our synthesis tool to synthesize it. So everything you need in a programmable DSP chain, but you can write your own special instructions using this capability. So there are over 7.5 billion of those cores. They're all around us. They're in every phone, they're probably on every computer. So they're all around us, but there's all kinds of different designs because it's a customizable thing. It's not the same design all the time. Each one of our customers will do something different with it. So as far as IP, that's my favorite piece of IP, sells very well. I have other IP, which IP is a very, very difficult industry because you have to have a team of people that understand it. If you want to sell 112 gig SerDes, you have to have a team of people that understand. Number one, they need to understand how to design it right. Number two, they need to be able to support it. That's very difficult because if you have engineers that know how to design 112 gig SerDes, they don't want to support it. They want to design it and go on to the next thing. They don't want to be customer support. So then you have to train people to support it, right? I'll tell you a little anecdotal story. I worked for this little aerospace industry, and one of my friends, Bill, he was really smart guy. And the economy was absolutely booming. And he decided at that point to go back and get his PhD. And I said, Bill, why don't you wait till an economic downturn and then go back and get your PhD? Because you can make money now, right? So one thing about timing is really interesting. If you're in an economic downturn, you kind of want to stay in school a little bit longer to see how that all pans out, right? Now, with that said, I don't think anybody doing hardware as a graduate student is going to have a problem finding work. It is just way too much out there. So in that case, in your case right now, I would say start getting into industry, because there are so many problems that need to be solved, so few people to solve them, and next year there's going to be a whole bunch of people retiring. We have a customer that has about 1,000 people retiring between now and the end of the year. 1,000 people. Now, probably 600 of them are engineers. So there's gonna be a demand. There's definitely gonna be a demand. That's in the aerospace and defense industry. Being an intern at Cadence and also maybe working for Cadence as an application engineer. So I use the analogy of like the three big accounting firms. I don't know if you have friends that are in the accounting realm, but they'll go to work for one of the big firms and then they'll have to go audit public companies. And they'll see, like, they'll work 60 hours a week and they'll get put in New York or San Francisco or wherever, and they'll work and they'll audit public companies and they'll see how different companies run. Well, working for Cadence as an application engineer is similar, because you will get put in a dozen different customers and you'll see all kinds of different design styles and you'll see all kinds of ways that things get done, and be able to talk to design engineers and managers and find out what's going on. So actually being a Cadence application engineer right out of college is a really good way to get a start, and it's a good way to like sample a bunch of different design styles and looking at different companies. This is the second time I've been at Cadence. I was at Cadence from 97 to 99, and then I quit, went to work for another company, and then I started my own business, and then I came back. I actually came back to Cadence because my daughter was starting school and I couldn't travel. I was a VP of sales for a small company then, but my daughter, my family would go with me wherever I went. And so I came to Cadence. One reason was because I just wanted to stay here in Southern California and just drive around and be home every night. I stay at Cadence because the people are amazing. I have some of the people work so hard. You know, it's a cult. It's kind of a cult because we do work hard and we're all up, and sometimes I'll see emails coming in at 9 o'clock at night. You know, Shruba, she travels, she works hard. And what I like about sales is that it's easy when you have your performance review, because you either sold up to or past your quota or you didn't. And if you didn't, then you have to start looking around for another job. So I like that part about sales. But Cadence as a whole is amazing. I mean, really dedicated people, from the sales team, the R&D team, you know, the marketing team. It's fun, and we are doing well. I will say, in our little industry, we're doing quite well, and we plow back 40% of our revenue back into R&D. So it's you know, and we're building out ancillary products into the system. This little Clarity product that Adrian says is okay, that's because we only came out with it 2-3 years ago. And so it's not the market leader, definitely. It will be in another 6-7 years. It will be the market leader, there's no doubt. And it's because of the people at Cadence. An application engineer is someone that's gonna go out to a customer site, sit down with the design engineer and find out why they are not able to effectively use the software that we sell. Does that make sense? Okay. And that requires a lot of capabilities. Number one, it requires you can't get upset in front of the customer. You can't call the customer, you know. So that takes a lot of skill, right? But you still have to be able to do the debug. You have to understand design. So that's like really an interesting, challenging job, right? Design engineer is also a very interesting, challenging job, because you actually dig way in there and figure out what's the best way to design this thing to meet this certain application. A product engineer also needs to collaborate with the customer. You need to try to find out what is it that the customer really wants to do. They might be saying they want to do one thing, but one interesting part about sales and working with many customers you start to find out that they're saying one thing, kind of like Adrian said, they think they know what they want, but you kind of got to get them to go up to a higher level, right? Because engineers being engineers, they'll kind of like drill down into kind of what really worries them, what they want to do. But if you extract that and pull it up to a higher level of abstraction, you'll find out that you can solve that problem if you just look at it from a little bit different point of view. So that's what we try to do with our products. We try to figure out, okay, what does the customer ultimately want to do? Can they do it with this product, or do we need to add a feature, or do we not need a totally different product, right? So product engineering is very interesting as well. So, did that answer your question?
Yeah.
Okay.
Well,
Looks like we have time constraints.
all good things end too soon, right? So we have another group
Okay.
needing a room here. But thank you, Doug, so much. And
Certainly. Thank you. Thank you. I'm glad you enjoyed it.
Tell your friends what they missed so that we can get more attendance. All those people who sign up but don't show up.
Thank you guys. It was fun. Thanks for being interactive. It's great. Good questions.